Hey guys, so today we're going to be solving polynomials in factored form and using the zero product property. So a polynomial is in factored form when it's written as the product of two factors. Two examples are listed below. So this is a polynomial in standard form, and we kind of saw that last week when we had to write polynomials in standard form. And then this side over here on the right is factored form, and we're going to learn later on in the chapter how to factor, but today we're going to just solve polynomials that are in this form. And in order to solve that, we're going to use the zero product property. So when one side of an equation is in factor form, the other side is equal to zero. So when we have this up here, it's like saying this is the factor form, so then the right side would be equal to zero, and then this side would equal zero. The solutions to the polynomial equation are called roots, and I'll point that out later as we begin to solve. So basically what we do, so we have our polynomial that's in factor form, and we just set each factor or each piece equal to zero, and then solve. So it's like you're solving two different equations. So we divide by 2, x equals 0, add 4, x equals 4. So I got x equals 0 and x equals 4. And we could check this by plugging it back in. So if we're checking x equals 0, so I get 2 times 0 minus 4. Does that equal 0? Yes, because 0 times anything is going to equal 0. And then I could check 4 as well. 2 times 4 minus 4. Does that equal 0? So I get 8 times 0. Yes, 0 equals 0. So you can check your solutions to make sure that they work. I'm only going to check the first one just to show you. Just plug in your solutions for x. Right, so if we keep going, so we said x minus 3 equals 0, x minus 9 equals 0. I'm going to add 3 to each side. So x equals 3, add 9. It's a 9. X equals 9. So x equals 3 and 9. Again, another name for our solutions. These are our roots, because our roots are equal to our solutions. Okay. And we could plug those back in to check to make sure. So we have 3t equal to 0 and t plus 2 equal to 0. So divide by 3. So t is equal to 0. And then subtract 2. T equals negative 2. So I got t equals 0 and negative 2. That's my solutions here. Let's write this one up here again to be consistent. All right, so then on the next page, sometimes when a root is shows up more than once, we have what's called a repeated root. So we might see that in some of the examples below, right? So if we have 2x plus 7 here, and we have 2x minus 7 equals 0. So we're going to subtract 7. 2x equals negative 7, divide by 2. So I get x equals negative 7 over 2. I'm going to add 7. 2x equals 7, divide by 2. So I get x equals 7 over 2. So for my solutions, I get x equals negative 7 over 2 and positive 7 over 2. Okay. All right, so for this next one, remember when we are multiplying binomials, it's like we have x minus 1 times x minus 1. They're both equal to 0. So we're going to set each piece equal to 0, and x minus 1 equals 0. Add 1. So x equals 1, add 1. So x equals 1. So this equation has a repeated root, so the equation has a repeated root of x equals 1, because x equals 1 shows up twice. Okay? All right, so then in number 6, we have 3 different roots. So we would set each one of these equal to 0. X plus 1 equals 0, x minus 3 equals 0, x minus 2 equals 0. Excuse me, we have 3 different factors, not roots. But we will have 3 roots as well. So x equals -1 plus 3, x equals 3 plus 2, x equals 2. So our roots are -1, 2, and 3 for this equation, okay? And then the last one, b plus 7 times b plus 7 is equal to 0. So b plus 7 equals 0, and b plus 7 equals 0. Subtract 7, oops, I'm sorry. So b equals -7 minus 7. B equals -7. So again, we have a repeated root because -7 shows up twice. So the equation has a repeated root of b equals -7. And there is my answer.